Okay, guys, here we go. Math workshop. Math workshop. All right, number 9. So, first of all, what's happening tomorrow? Workshop test. We got factoring's going to be on there. We got radicals going to be on there. We got logarithms, natural logs, base E is going to be on there. All that good stuff, right? Okay. All right, let's look at number 9. This is a radical problem. How do you rewrite this guy into exponential form? 2 to the 3/5 power. Very good. Ooh, that's in red. Okay then. Just rewrite in red. There we go. All right. What about 1/2 power? What's the 1/2 power? Radical and the y. Very good. So square root of y. Very nice. Very nice. How are we doing? We okay? No? No? Yeah, we're okay? All right. Grab your Grab your ACT. Let's go over your ACT stuff real quick. What are we on? 32, I think. All right, 32. There was, it said something about give me the y if they give you the x, right? Something like that. Okay, what was the equation that they gave you for 32 with that graph?
0.005x squared minus 2x plus
Plus how much?
200.
Okay, and what was the x value they wanted you to use? 20. All right. So all you had to do was plug in 20, and that was it. All right, take your calculator, plug all that stuff in, see what you get. 162. Somebody second that?
Yes.
Yep. All right, so what answer choice is that?
G.
G. All right. 33. Is that the one with the picture, right? Like that.
The curve is longer than FG, about how many quarters she has longer than FG.
All right, is FG right here. So you're trying to find this guy. That's what you don't know. Well, you know how tall it is. How tall is it? 200? And you know how wide it was. How wide was it? 200. All right, sorry, Pate. All right, so if you've got side A and you've got side B and you're looking for side C, that's what diagram theorem. So 200, yep. All right, let's see. 200 squared plus 200 squared is 80. 1, 2, 3, 4, 5, 80,000? 80,000? Okay. Just make sure I have the right amount of zeros. All right, square root that, and you're going to have to do that one. I can't do that one. Are they rounding? Yeah, but look at our answer choices. Our answer choices are whole numbers. 283. All right, and that is D. How are we doing so far? We're good?
Yeah.
All right. Last one it was real wordy, but it was very easy. Okay. Do you see that line FG is your hypotenuse? Mm-hmm. Is that curve under the line or above the line?
Under it.
So is it less than, the same, or greater than?
It's less than.
It's less than. So you only had 2 answer choices, which was either F or G. Now, one of them said it was under, and one of them said it was over.
F says it's under.
F says it's under the curve. Very good. So it should have been F because that curve is under F and G. So if you got it wrong, just fix it, okay? How'd we do?
Good. Perfect.
Good? All right. Okay, don't let those words scare you. On 34, that was just a whole bunch of words, okay? All right, go ahead and grab your notes. No, you're not doing that. If something happens, no. Not going to be on my watch.
You do have to like
No.
Wait,
No.
so why are you still doing this one? Is that like the way you like it now?
Yeah, because it's just hard with this stuff. It's just hard to. I'm going to order a cart like this for Hester has so I can roll around and keep it flat. But this thing, you can't keep it flat, so I'm going to do it like this until I get a cart. All right, here we go. On page 6, 7, 8. Page 8. Page 8. At the bottom of page 8, there's 3 little boxes down there. You see it? Okay, so this is the hardest part about today is remembering when to use which one, okay? All right, the first one says bigger degree on the denominator. So degree was the biggest exponent, right? Remember that from way back when? So if the biggest exponent is on the bottom, you're going to have a horizontal asymptote at y equals 0. All right, so in that box, write y equals 0. We're going to do plenty of problems. All you got to do right now is write them. All right, the second one says the biggest degree is in the top, the numerator. If that happens, you don't have any horizontal asymptote, so no horizontal. I could spell. Remember what asymptotes were? Do you remember at least what they? Remember at least hearing the word? Please remind me. You remember hearing the word? Some of you do. Oh Jesus. Okay.
Is that the one where,
We'll talk about it. Just a second. Let's do this first. All right. Last one says the same degree. That means the degree is the same on the top as it is on the bottom. And if that happens, you divide the coefficients. All right, so all three of your boxes should be filled up. And that's the hardest part about today, is knowing when to use which one. Just remembering all three of those. All right, we got 3 problems. Here we go. We'll use blue. There we go. All right, number 1. What's your degree on the top? 2. What's your degree on the bottom? 2. So they're the same. So you divide their coefficients. So you have a horizontal asymptote at y equals, the coefficients are 1 over 2, so y equals 1/2. That's it. That's all we got to do. How are we doing?
What do they do with the plus 2 and minus 1?
Nothing. All the directions said to do was find the horizontal asymptote. That's it.
I'm guessing that later in school we'll figure out what to do, but we find out what we do with those.
Later, yes. All right, number 2. Here we go. All it says to do is find the horizontal asymptotes. Okay. So what's the degree on the top? 3 x cubed. There you go. What's the degree on the bottom? 2. Which one's bigger? On the top, look on your little cheat sheet. When the numerator had the biggest degree. White.
No,
There's not one. I'm sorry. I just messed that up. I was thinking. Wait, no. This thing does not want to erase. No horizontal asymptote. I'm just going to abbreviate. All right, what about number 3? What's your degree on the top? 2. That's the biggest exponent. What's the degree on the bottom? 3, because that's the biggest exponent. The bigger one's in the bottom. So where is your y equals 0? So horizontal asymptote at y equals 0. How'd you do? You okay? Not that bad? Where?
I have to do it more like it's just.
It's just a little confusing about when to use what.
Yeah.
All right, let's go to the next one. Next one on the next page. Here we go. Next page. This one doesn't ask for the horizontal asymptote. It says find the points of discontinuity and label them as what? I'm reading directions on the next page. Vertical asymptote or hold. All right, here's what you need to know. Write yourself a note on the top somewhere. Here we go. Write yourself star it, put your little note at the top. All right. To have a vertical asymptote, that is where the bottom equals 0. Where the bottom equals 0, you got a vertical asymptote.
Oh yeah, like on the bottom.
All right. Where something cancels, that's where you have a hole. Where something cancels, that's where you got a hole. Okay? All right. All it wanted you to do, it doesn't say anything about horizontal. All it says on 4 through 9 is to find the vertical and find the hole. That's it. You all okay so far? All right. So to do that, you got to factor. How's the top factor on number 4? There you go. And the bottom? X plus 9 and negative 5. Very good. Alright, does anything cancel out like we did back at 8.1? Nope, nothing cancels out, so I don't have a hole. But where the bottom equals 0 is where you have a vertical asymptote. So you have a vertical asymptote at -9 and +5. And that's all she wrote.
Okay, but what's the purpose of this?
If you flip over.
I'm trying to like piece it together, but I'm like,
What are we about to do?
Nothing.
That's the purpose of it. We about to graph these bad boys.
So the vertical isotope is literally just what X cannot do in a normal
We're in the
graph.
bottom of the denominator. The bottom. Alright, let's go to number 5. Here we go. Number 5. How's that guy factored? So 3x minus 1. There you go. And then? Very good. Alright, does something cancel on this one? Yes. Alright, so if I were to set x minus 1 equal to 0, where would my hole be at? X equals 1. So you have a hole at x equals 1. That's the piece that canceled. If I were to set x minus 1, you just add the 1 over it. If you set it equal to 0, you get 1. Alright, now what is left? Once those 1's cancel, what's left on the bottom? X plus 4. That is the piece that's your vertical asymptote on the bottom. So your vertical asymptote would be at x equals, beautiful, and that's all she wrote. Because that's all it wanted us to do in the directions. We okay? What's wrong?
I'm still not really understanding.
Alright, let's do the next one. Let's do 6. You ready? Are you good on factoring? Okay, well let's factor it. This becomes x plus 2, x minus 2, right? And then the bottom is just x plus 2. You good there? Alright, well, what happens? X plus 2 is canceled. Well, we made ourselves a note. Very good. Alright, is anybody lost about that? Because if you were to set x plus 2 equal to 0, the x would be -2 when you subtract it over. Alright, now the vertical is where the, hold on. The vertical is where the bottom equals 0. The only thing left is x minus 2, and there is no denominator. So there would not be a vertical asymptote on this one. Kind of, sort of?
Why would there not be a
Because you don't have a denominator. The denominator canceled out.
So there can only be a vertical
If there's a denominator.
So,
Yep.
and there's no
Yeah.
vert.
There's no vertical at all because there's no denominator. That's it. Good to go? All right. Let's look at, we did 6. 7. You factor 7. You factor 7. And then we'll go from there. This is big on the ACT, okay? Especially this factoring stuff. Yeah, you factor 7. All right, how'd you get at the top factored? Very good. Doesn't matter the order, as long as the bigger number is positive. All right, what about the bottom? Very good. And what happens? Now, where something cancels, you got a hole. Where you got a hole at? X equals 2.
And the vert is negative.
Why is the vertical asymptote at -1?
Because you subtract the over.
That's on the bottom. Very good. And you subtract it over and you get -1. Very good.
Wouldn't there be another one at the top? Would be -3?
No, only with the bottom, because you only undefined on the fraction. Because look, type in the calculator. You get 0 over 9. That's 0. That's defined. But if you do 9 over 0, your calculator's going to go.
Because nothing times 0 equals.
Yep. All right, number 8. No, is that it? Yeah, 8 and 9. You try those two. 8 and 9 are all yours. You try those two. You factor them out. On 8 and 9. Yep. X equals 3 minus 3. X equals 3. All right, did y'all get that number 8 factored as x plus 3, x minus 3? Nothing canceled, so you don't have a hole. But where's your vertical? So we would just write that as plus and minus 3. Very good. Don't write plus and minus 3. It's x equals plus and minus 3, okay? Because it is an actual line, which you're going to see in about 10 minutes. All right, number 9. Did you get that one factored with a GCF? And that those cancel? So you only had a hole at x equals 3? All right, you're left with 4 over 3. Is your denominator ever going to change from 3? No. So there's no way you can have a vertical asymptote. 3 is never going to change. We good? Okay, listen.
Wait, can you say that again about the
Yes.
vertical?
The vertical asymptote has to be where that denominator equals 0. 3 is never going to become 0 because it doesn't have an x with it.
Okay.
So he's always going to say 3. So we're good to go. We will never have a vertical asymptote. All right, here's what I want you to do. I'm going to give you about 7 minutes. And we're going to look at 1, 2, 3, and 4 all on your own. But what does 4 tell you to do? What does 1 through 4 tell you to do first?
Find the horizontal.
Find the horizontal asymptote first. Then you go through and you factor and you do all your good business and you cancel stuff out and you do your vertical asymptote and you hold. So do your horizontal asymptote first, okay? So I'm going to pause the video and we'll put some tunes on real quick. Yay. We need to do this together. All right, let's look at this together on 1. Horizontal asymptote, guys. Look back on your cheat sheet with those 3 little things. Horizontal asymptote. You have the same degree on top and bottom. So what is your horizontal asymptote? Y equals 2 over 1, which is 2. Okay? Y'all good to go with that? Did y'all just not write it down or something?
I didn't write down until we can post it.
Okay. All right. Well, all right. Keep going. Huh? Y equals 2? All right. I just didn't see it on most of y'all, so y'all have to just write it. All right. Keep going. Keep going. Look at it. All right. All right. What about your vertical? Where's your vertical out on number 1? X equals 6. Very good. All right. What about number 2? You've got no x's on the top. You got 2 x's on the bottom. So your biggest x is on the bottom. Here we go. All right. I got a phone call.
This is the first time you got a phone call?
Yeah, the office, the intercoms are down, so the office is calling.
I'm not taking a picture outside.
Hello? Can I send her in like 10 minutes when we finish these notes? Yes, ma'am. Thank you very much. Miss Owens wants you just a minute. C202. C202. So you go down this hallway past the rotunda, turn left, and she'll be down there.
Hey, what happens if you tell them no?
Just come some other time and her asking you some bullshit. All right. What about the vertical asymptote on this one?
Like, can we have somebody check out? No.
What's vertical asymptote? Plus and minus what x equals plus and minus 2. There you go. Well, if someone's parent comes to get them, I have no business telling them.
No, I was just like, I know you would say no to like somebody's parent, like, and then like Miss Billy going to see you, just like said no.
Well, I just simply very politely asked if she can come at a different time.
So you said no.
No,
Why
you
should I-
don't. You don't
no.
talk to people that way. That's not how you talk to people.
All
All right. What about?
That's how you run this call.
All right. What about number 3? You got the same x on the top and the bottom, right? All right. So what do? Divide the coefficients. So y equals 1 over 1, which is 1. All right. What about vertical? Very good. X. I don't know why I just spelled that whole word out. Very good. X equals 1. All right. Number 4 had a GCF of 2. Pull the GCF out first, which leaves you with x squared plus 5x plus 6. All right, over x plus 3, x minus 3. Alright, now how does x squared plus 5x plus 6 factor? Positive 2 and positive 3. Very good. Alright, and then what cancels? X plus. I'm getting too close to the edge. There we go. So you get a hole where it cancels at x equals -3. You got a vertical asymptote
Just 3.
of just x equals 3 because that was what was left on the denominator.
And your horizontal is y.
All the way back at the beginning. Very good. 2 over 1 is 2. Did I lose anybody?
Look at us being math.
Look at you go. Everybody okay?
If we didn't split the GCF at all at the top, would you count that?
Yes, because if you didn't pull the DCF out of the top, then it wouldn't cancel. I think it's canceled.
It still canceled for me.
Did you get lucky?
Yeah, like if you, I
You get
did it
lucky
different ways,
sometimes.
it still counts as
I
all.
did too.
Yeah, so not all the time. Like, when you do it, it will not all the time pull out that DCF or make it where you can cancel. Like there's certain cases that I've seen it before where it won't do it. All right, let's look at some graphing. Kat, go ahead, Bobby, and go see her real quick because this is the same thing we're just
I
going to
should
have
have
to
done myself first.
She didn't take two. I think she took something real quick. Okay, flip over real quick to the next page. And we got 2 problems we're going to look at. This is where you need your graphing calculator. If you don't have one, go get one real quick, okay? Flip over on the back of the page we were on, page 10. All right, we are not doing all of these today. We are just doing one at a time. We're going to do 2 today. 1 and 2. All right, in order to graph it, you got to tell me where the asymptotes are and where the holes are. So let's start with the horizontal one first of all. You have no x's on the top, and your degree is 2 on the bottom. So
0, right?
that's the biggest ones on the bottom, and what's the biggest one on the bottom mean?
Y
Y equals 0. So you got a horizontal one at y equals 0, which is basically just your x-axis. And we denote asymptotes because they are invisible with a dotted line.
We need a
wait.
dotted line. We can't really because it's
You can make it dark enough that you can see it with your pencil. How are we doing so far? Not bad? All right, here we go. What about your vertical is where the denominator equals 0. So how's that guy factor?
X minus 4, x plus 3.
Very good.
Thank you, I appreciate it.
Oh, no, what just happened? X minus 4, x plus 3. All right, so where's your vertical at?
X.
Positive 4 and -3. So that's the vertical line. So you go to -3 all the way down the graph and put your dotted line.
Is everything dotted on this thing?
No, just the asymptotes. The vertical asymptote was at -3. X equals -3. So I went to x is -3 and I drew my vertical asymptote.
Wait, let me start putting this solid on.
We're not. Wait, patience, grandpa.
I tried to.
All right. Then we go into 4. X equals 4, and we put a dotted line down that guy. Yes, ma'am.
Are holes dotted lines too?
No, holes are like physical. Like you would literally have a hole in the ground and you step over it. That's what the graph does.
That's
Yeah, I
pretty
didn't
crazy.
know that when you said hole that.
No, like it's an HOLE, like an actual hole.
It makes sense though, because when you exit out, it's not really.
Yep. It's like you have a hole in the ground. So you have a hole in the ground and you go to step and then you step over it.
Yeah.
It's the same thing the graph does. It literally jumps from this place over to that place. It jumps. It's a hopping graph. Yep. All right. So here's what we're gonna do. We're gonna talk about asymptotes real quick. So on the road, you got these little dotted lines you're supposed to stay between. Hopefully, Lord Jesus, tells you do. Okay. You're supposed to stay between these dotted lines. What happens if you go over to one side? You're gonna run into somebody. If you go over to the other side, you're going to run off the road, right? So it's the same thing with this graph on these asymptotes. It's the same thing with this graph with these asymptotes. It guides the graph and tells the graph that it can't go past these asymptotes on either side. It can't cross over it. Does that make sense to everybody?
Yes.
All right. So
Where's the graph gonna be at?
in between all this then. All right. So take your calculator. Hold on. Go to y equals.
The graph need AAA.
It's a little bit funky. It ain't gonna need AAA. It really does because it's a little funky. So when you type it in, what was it? 3 divided by something? Right that.
3 divided by x squared minus x minus 12.
Minus x minus 12. Notice how I put the denominator in parentheses, okay? Notice how I put the denominator in parentheses. Don't freak out when you hit graph because it's going to be a little funky, okay? 3 divided by all whatever number 1 said.
Okay.
All right, now hit graph.
So this graph is what it wanted to do, huh?
Well, no, it don't do whatever it want to do.
What?
All right, let's look at it. Can you see your asymptotes?
Yes.
Can you see that it is not going below? This graph on the left does not go below 0. This graph on the bottom does not go above 0. This graph on the right does not go below 0. Y'all okay with that so far?
Yeah.
All right, and then there was a positive 4. Do you see how this line runs right along positive 4? And then negative 3? Do y'all see those?
Yes.
So it's just like, separate graphs.
Yes. They're 3 separate graphs.
So if you hit table, what happens?
You have the points, but mostly they're decimals. If you go to your table, okay, so let me look at this.
Error.
Why did you get an error at x equals negative 3? What's there?
That whole,
That's not where a hole was.
that's the
The vertical asymptote. You should have written it down. It should be right there in front of you. Vertical asymptote. All right, then there was another vertical asymptote. Where was it at?
positive 4.
So go to positive 4.
Error.
Error. There you go. How we doing so far?
Doesn't have.
Because 0 is the y. If you notice that none of these y's will have zeros. It won't put the y's on there. It'll put the x's on there.
Okay.
All right. So do we have any decimals that are good enough decimals that we can graph? I have 0.5s. Negative 2. All right. Let's graph those. At least graph those. Graph what we can. Negative 2 and 3. Sometimes you will, but not all the time. Sometimes you'll have whole numbers. This one doesn't have very good one. All right, negative 2 and negative 1/2, and then what was it, 3 and 1/2? Negative 1/2? Huh? Okay, thank you.
Is that you play Minecraft?
All right, that's all my decimals. My decimals are crazy. All right, so go to your graph, and we're going to mimic what it looks like. Okay, so what does it look like? It rides right along negative 3, and then it comes through these 2 points, and it kind of straight lines, and then it goes back down. Everybody okay with that so far? Yeah? Yes, stop that.
So the one in the middle would pretty much. So the one in the middle would pretty much be like kind of like a positive infinity, but it never touches kind of deal. Like where it keeps going this way, but it will never end up touching it.
Try that again. Try it again.
That's the difference.
It's like
No.
It's kind of like that
It starts to move to the right a little bit, but it never touches it. It will
Touches
keep
what?
the vertical.
No, it will never touch the x-axis because there is a horizontal asymptote there.
Yeah, so it pretty much moves closer towards it, but it
But it will
never
never touch it.
Okay.
Alright, so then the one on the left ran right along the x-axis and then shot straight up after that, right? Bless you. And then the one on the right ran straight along the x-axis and then shot straight up like that. How we doing? We okay?
So it does or does not have to go?
It does not. It will never.
It goes one next to it, right?
Very, very extremely like 0.9999999 next to it, but it will never actually physically touch
I'll
it.
just keep adding decimals over.
Yes. All right, let's look at number 2. Number 2. Same thing. Last one we're going to do. Last one is number 2. Taylor, how we doing? You with me at least? Yeah. Okay. All right. Kind of. All right. Let's keep doing some more. Let's do one more. You got y equals x squared plus x minus 6 and 3x squared minus 12. So how's the top factor?
X plus 3x minus.
Beautiful. All right. What about the bottom? GCF of 3 first. Bless you.
Minus 2 and then x squared. And then 3 is x plus 2, x minus 2.
Very good. 3 and then x plus 2, x minus 2. Very nice, very nice.
And then x plus 2 cancels.
X minus 2's cancel, which means that's a hole. There you go.
Can't wait to see what this is going to look like.
It literally is just a circle for a hole.
Nah.
Like,
Spoiler.
the graph going to go.
All right, well, we'll get there. We'll get there. All right, what about a horizontal one? Go back to the very beginning. Y equals 1/3. Very good, because they were the same x squared and x squared. So you took your leading coefficients 1 and 3 and you divided them. All right, what about a vertical asymptote? Very good. X equals -2 because the 3 does not have an x, so you're not worried about him. How are we doing?
Good.
Good so far? All right. Go to your calculator. Go to y equals. Clear it out. All right. Now you're going to use parentheses around the whole numerator. Negative. Very bottom equals -2. X equals -2.
And the whole was.
Positive 2. Positive 2? Yeah, positive. The whole. The whole was a positive 2?
That's right, yeah.
Okay. All right. What was the numerator? X squared plus. All right. And then I close my parentheses after my numerator. And then I hit divide. And I'm going to use parentheses again for my denominator. What was it? 3x squared minus 12? Okay. All right, then hit graph after that. You still got the same kind of thing going on. You got some craziness.
Oh,
Where?
is that where the hole is?
Yeah, that's square. X is 2. What did it? X is 2?
Yeah, x 2.
Okay. Now, your calculator is... Yes, ma'am. Alright, your calculator is not going to actually physically draw the hole in because the hole is like so minutely tiny that it can't do it without.
It's like basically like a stick. I'm sorry.
So what happens, because see look, it's only at the 2. So right there where that 2 is, there's a hole. We're going to actually physically draw a hole so that we can see it, okay? But your calculator won't do it because, like literally, if it's 2.0111111, it's still good. So your calculator can't draw the circle big enough so that you can see it, but still small enough that it's exactly. So that's why it won't draw it in here. But if you go to your calculator, Caleb, go to your table. What was it? 2?
Error.
There you go. Error. So it still tells you in the table that it's an error. What were the other x equals? -2? Was that one of them?
Yeah, that was the first.
And there you go. So your calculator lets you cheat. You kind of get to check your work a little bit, right?
Yeah.
Okay, but you're still going to have your work on there to get full credit. All right, do we have any good Oh, look at there. We got -3, 0. That's a good one. We got 0 and 0.5. Those are both good ones. Oh, wait, we didn't put our asymptotes in yet. Hold on. Let's do those first. All right. So 1/3 is just barely above the x-axis. I mean, it's like, for me, it's really hard to draw because mine are so small. All right, what was the other one at? The vertical was at 2? -2? All right. All right, when we draw our graph, we'll put a hole at 2. All right? Because the circle could be, if the graph goes up here at 2, the circle will be up there.
Oh, okay.
If the circle's down here at 2, it'll be right there.
How do you know
If
what the hole is?
Well, you look on the graph.
There's 0 and then 0.5.
All right, let's put all of our points. What did we say? -3, 0? Is that what we said?
Yeah.
1, 2, 3, 0. Now, your point is going to look like it's kind of on the asymptote, but remember, it's not actually there. It's just really close. All right, what was the other one? 0 and 0.5? Is that right?
0.5.
All right. Let's see if there's anything else. Are there any other?
3.4.
No, we already got one real close to that. I think that's it. Those are all too small. Did y'all find any other ones? No? No. All right, that's it.
Well, there's 12.
12? Well, that's 0.3. That'd be fine. And I don't really want to make my graph -12 anyway.
Every negative says.
All right. Oop, wrong button. Let's look at our picture. What's happening?
It's a lot.
It's a lot. All right, what's happening here? It's going to flat line, flat line, flat line, and then what happens?
Curve down.
Straight down, right about -3, right? Okay, so right about that point that we put, right about there, then it shoots down. All right, put your arrows on both ends. All right, let's do the last one. Here we go. What did it look like?
Why is it negative?
Did I put negative? I think it was positive. I think I put that in the wrong spot. All right, last one, and then we're done. Okay, here we go. So it flatlines, it flatlines, it flatlines, and then at 0.5 it goes across, and then at 2 we're going to put a hole, and then it flatlines, flatlines, flatlines. How'd we do? We okay? All right, go ahead and put your step in the safe spot. Make sure you got that physical hole at 2. So when you get to 2, you just have a hole right there.
Go in the grass like it's an open dot.
Yes, because it can't. The graph can't be at 2.